Hello friends, welcome to Clarify and Decode. Today we will look at designing resilient APIs. So it's very easy to write clean functional codes building APIs that will work flawlessly, but we forget what will happen if there is an error in between the APIs. And this mindset can lead to problems in production. So designing resilient APIs is of paramount importance. Basically, what we are trying to achieve is, even in cases of failures like disruptions, any unexpected conditions, right, there should not be something that is very bad to the users. So the goal is to maintain availability of the system, and it should remain functional with good data integrity and without impacting user experience. So let's see what are the options we have and how we should go about it. So let's assume a scenario. We have four APIs: API 1, API 2, API 3 and API 4, and the flow was like this. But suddenly the call between API 3 to API 4 is failing. So for data integrity, what you should do? One option is to revert back all the transactions, all the entries, or compensate whatever we have done to be in a good state. So the term here is compensating transaction, and that too we see it with the saga pattern. Okay, I will explain more about the saga pattern in this video itself, but just think it as a compensating transactions. Fine. So saga, as you would know in normal English, is like a big story with a lot of events, good events, right? Here what we are doing, there were events, right? API 1, 2, 3, 4, and then we reverted the events. We compensated it. So we relate saga to what is happening in fictional movies or turnaround movies. Let's focus on where it is useful. So whenever we have something like a payment system, or where we cannot afford to have the API status or the DB status in a different condition from the start, then we have to definitely compensate. Good for distributed transactions. So as I mentioned, if there is a payment is failing, we have to definitely refund it, right? And whatever we had booked it, maybe a mobile inventory or other things, we also need to release the inventory. Suppose there was only one mobile left for the iPhone sale, and we thought, okay, it's okay to utilize the inventory. It should not go like that, right? We need that inventory to be returned as soon the payment was a failure. So this is the first thing we have to think for compensating it with the saga pattern. This is good for data integrity. How the user cannot be affected, the end user experience, we can just think of what we will show whenever there is an exception in the flow. That is up to the business or the BA. Okay. Second, what else we can do? Here it was failing, right? But we don't know why it was failing. Maybe there was a temporary network issue. Maybe the API gateway was down, right? Maybe something at the user end. So we can think of retrying the transaction or retrying the API calls. So this is the retry pattern. Okay. But here we have to be cautious, like it is just for like very small duration issues. We cannot hang on this, right? We keep on retrying, right? It's not for persistent issues. It is just for transient issues. Okay. as I said, payment gateway retry, maybe network issue, gateway issue. And there are options how we go about the retry pattern. We can think of exponential back off, like we are not using the same retry value or in how much time it would call the API again. We can think of something exponentially. Okay, call in next 10 seconds, after that call in next 15 seconds, something like that. And a limit to the retries, like just retry 5 times. Okay, fine. So we told about compensation, we told about retry, when to use them. Third is the circuit breaker. Let's relate it to the normal word. Let's clarify it. So, in electrical systems, what is a circuit? Something like this, right? The flow is there and it is going somewhere else. And if we need to remove this flow, what we will do? We'll just cut off one of the things, right? Like this. And we told we have broke the circuits. We have removed the circuit. This is the similar concept. So suppose this flow was causing the issue, right? So we cannot keep calling the API 4 forever. Of course, we just told about the retry option and some limits. Apart from the user's perspective, we also have to think about this at our end. Okay, just a minute. Yeah. Why? Because maybe the API 4 is not responding. The server may not have a good CPU. There may be some infra problems. The RAM may be full, right? And if we keep calling that, it would add to its concerns, right? It would not heal itself. So we give some time to recover. It's called cooling off. So if it was something like that is can be self-healed, or if we just give it a hold for some time, maybe it recovers itself, right? So we have to just break the circuit to save the resources for API 4 server. There may be n number of other scenarios where we can use this circuit breaker, but the thing is we are just cutting it off for our own sake, for the system's sake. Maybe other things are also dependent upon the API 4, and maybe here also we will save some infrastructure compute options, right? It's the same things. Stop calling 4, and we are avoiding cascading failures here. Means if we keep open the flow, maybe API 5 is also getting affected, right? Fine. So these three are the, I would say, top options. We have others as well, but these are the most frequent used ones. So now let's get back to the Saga one. What is Saga? So there are many API flow patterns. The most common we would see is Saga. There is something like bulkhead, event driven, and other things. In context of resilience, we will also talk a bit about other patterns. So Saga, series of events. Think of a good movie, right? And when there are sequence of APIs or interdependent API calls, how we can do that? We have two options. One is called choreography and the other is called orchestration. Okay, so think, what is a choreography? It's like we are changing the steps that we have pre-practiced based on some music or some tune or something. So it's choreographed. Okay, after this 3 beats, do something. So this is what is choreography saga pattern in APIs as well. After this event, just call this API. Okay, so it's event based. Orchestration, if you go to an orchestra or like a opera or like there is a music director, right, he will give you when to go about what. Okay, he will signal it through his hands, he would orchestrate, right? So here we have a central controller which is causing or communicating all the sequence, like the main API through which the flow is happening. Suppose in an e-commerce system, there's an API which takes the booking, the method returns, okay, the booking is good, the method would propose something in the UI for payment, user will enter, the main API would then ask for the payment gateway. So everything is driven by a central character, orchestrator, right? Fine. Okay, so 3 patterns I told you what we can do. What we can do for the users apart from this in terms of functionality, we have to think of graceful degradation. Okay, we will continue to work. We can just say, hello, our payment system is facing some issues, please come back after some time. Or there may be an option where you take the payment in a queue and say to the user, we have taken your request and we are trying to process it. We are not completely shutting the system. Not other APIs are like switched off. This is the graceful degradation part. As I told, async operations, it's better sometimes even for scale and sometimes even for availability. And here, for case of resilience, we can have not the direct operations, not the synchronous operations, asynchronous operations. So we take everything in a queue, okay, or a background process somewhere else, and we try to process it. Somehow we will try to process it with retries and other mechanisms, okay, but it is not breaking the functionality and user is having a good experience. Retry with MQ. For sake of debugging in future, okay, or if it is a async system and in the async flow also something is not going right, how do we like manage it? So we have to have good monitoring, okay. So all the APIs would have a same structured log and we would put it in the same centralized system and we will have a correlation IDs, okay. So transaction XYZ API span for booking and then XYZ and then we relate everything, and there are a variety of tools for this, but the basic point is good monitoring and logging. Timeouts already mentioned, it's a similar concept which is coming with retries and fail fast, okay. This is also an important concept. If we see something where we know we can have issues if our data is not consistent, if any of the entry is not in correct format, we can just fail fast, okay. We don't keep open the flow just for the sake of it, just expecting that it will work or can be handled at a later stage, okay. So suppose beforehand, like in the booking flow only, we know we have a health check for payments and there only we saw, okay, the payment is not going well, we may design a different system. So then we don't need to call all the layers and then reach payment and then say, okay, payment was down, right? We can fail fast and inform and have a good experience to the user. Fine. Okay, just a quick recap. What we are doing: compensating transactions, we are retrying, we are breaking the circuit. There are other methods as well. These are not so commonly used, but they are picking up, right? So bulkhead pattern, let's clarify in terms of what is a bulkhead. So whenever we have big ships for carrying containers, right, we have compartments. It's not like a big hull, and these are called bulkhead. So maybe we are putting some kind of commodity here, maybe the priority commodities are here, maybe coal is here, right? So what happens is everything is not getting mixed. If there is some issues here, like it crashed, then we are at least safe for these compartments of bulkhead. So similar concept in APIs for resilience. Don't have everything in the same resource pool. Okay, don't give same powers, don't give same connection limits. Okay, in essence, like one API should not prevent other APIs to like go down, right? And the second is event sourcing. Let's take from the example. So we are not updating the same record like in a DB or wherever we are like having the entries, but we are having separate records like logs. So okay, the order was placed, fine. After that, the payment was initiated, fine, and then the payment failed. Okay, so it is separate. So even if the payment was succeeded, we will still have this entry, payment initiated. So either payment initiated went to payment failed or payment successful. If there is failed, we'll have a mechanism to identify it and replay the next events, right? So this is event sourcing. Store actions as events. Fine. Okay, just the closing points. What else we can think of? Rate limiting. Okay, like there is something we know, this is our peak capacity of throughput we can handle, so limit it. Like okay, let's wait for other requests. Design something like that. Of if there is a DDoS attack and there are a lot of API calls just for dummy bookings, limit it. Okay, your system would be more resilient. Okay, cache responses. Suppose an API is failing, but still you can have some default or cache response. Like you may have a list of models of iPhone, it will not change over Android. So whenever you have an API endpoint which was giving these are the responses or these are the list of the phones, you can have it cached, right? Even in the flow we are calling that API and that is false, and then we can go to the if else block, or like even in the exception block before logging the exception we can have the cache response. It would be more resilient. User will not face or see a big problem. And the last one, because irrespective of what we do in production, it is meant to fail, right? Or give some signs of going bad. So do chaos engineering. Just break some APIs in the flow, see what is happening, how your system is behaving, have some test scenarios for this. There are even tools that help to do chaos engineering, or you can just build your in-house test cases, test system for such scenarios. Fine. So it's almost 20 minutes. Let's wrap it up. It's very important to have resilient API flows. for user experience and also for our system consistency, right? What we can do, we can try compensating first, we can try retry, we can try circuit breakers. Okay, these are the top three. Have this in mind, and the other ones, other examples that I showed, you can think of that as well. Okay, thanks friends. In a related video, I will try to explain more on the API design patterns, what else we have, and we will try to see the advantages and disadvantages of them. Let's stay tuned. See you in the next videos. Please do subscribe and like if you are finding something useful out of my videos. See you.